Welcome to this explainer. Look, let's just be honest for a second. If you've ever opened a brand new NestJS project, you probably felt, well, pretty intimidated, right? You're staring at all these decorators slapped everywhere, these empty-looking classes, and folders labeled with cryptic things like DTO. And you're just kind of sit there wondering, okay, where does the logic actually start? Well, today we are going to translate all that intimidating boilerplate into real-world, totally understandable logic. We're going to demystify NestJS from absolute scratch so that instead of seeing a confusing jumble of code, you'll clearly see the blueprint of a highly structured skyscraper. Let's dive right in. Now, to really grasp why NestJS is built the way it is, we kind of have to look back at where you might be coming from. If you're an Express developer, you are totally used to the wild west of manual wiring. You know the drill. You use app.use, app.get, and honestly, you can practically see every single route and middleware in one giant file. You wire it all yourself. Then on the complete opposite end of the spectrum, there's something like Meteor, which represents hidden magic. Data just magically syncs itself, and the framework makes 100 decisions behind the scenes that you never even see. NestJS, well, it sits somewhere entirely different. It forces you to make every single decision yourself. Absolutely no magic, but it gives you a very strict, specific vocabulary of about 30 words to make those decisions consistently. And today, we are going to master that vocabulary. So here is our game plan for this explainer. We are going to construct our mental building in 4 phases. First up, the basic office hierarchy. Second, securing our API borders. Third, we'll head down into the engine room. And finally, we'll talk about enterprise scale. All right, section 1, the basic office hierarchy. This covers the day 1 vocabulary you absolutely need to get started. The very first thing that always seems to trip people up is that a NestJS application is not just a flat list of files. It's actually a tree of modules. Think of a module exactly like a department in a large company. Let's say you have an HR department. That department owns its own staff, its own tools, its own filing cabinets. Now, if HR needs payroll data from finance, the HR manager doesn't just walk into the finance office and start rummaging through their desk drawers, right? That would be chaos. Instead, they formally request it through a defined interface, and finance decides exactly what they want to share. In code, a module declares what it imports, what its controllers are, its internal providers, and what it exports for others to use. The golden rule you need to commit to memory right now is this: 1 feature, 1 module. Never, ever try to build one giant app module that does the whole shebang. Okay, let's move on to the controller. The controller is simply the entry point for your HTTP requests. And there is an absolute hard and fast rule here. Controllers contain 0 business logic. Not a little bit, 0. No if statements about your data, absolutely no database calls, nothing. Think of the controller strictly as the receptionist at a medical clinic. When you walk in the door, the receptionist takes your name, asks your reason for the visit, and routes you to the correct doctor. They might hand you some paperwork when you leave, but they do not examine you, and they absolutely, under no circumstances, prescribe your treatment. They just route and return. If your controller method body is longer than 2 lines, you are literally doing the doctor's job at the front desk, and you need to stop. And that brings us perfectly over to the service, which is, you guessed it, the doctor in our clinic analogy. The receptionist routed the patient here, and now the actual real work happens. The service is where all your business rules live. The doctor examines the request, applies all the necessary medical logic, maybe checks your history, and then prescribes the treatment. Notice how the doctor does not answer the phones at the front desk? It's the exact same concept here. A service never, ever deals with HTTP-specific objects like requests or responses directly. The doctor does medicine, the service does business logic. Our next key term is provider. Now, this is basically an umbrella term for anything the NestJS dependency injection system manages. So your services, your database repositories, your custom utility classes, they are all providers. Think of them as appliances that you plug into a power grid. The dependency injection container is that grid, supplying the electricity. When you see that @injectable decorator in the code, that is quite literally the physical plug on the appliance. But just having a plug isn't enough, right? You don't wire these appliances into the wall manually. You register them in your module's providers array, which essentially tells the power grid, hey, this appliance exists and it needs power to run. So our basic clinic is completely set up. Your API exists now. But we have a major problem. Right now, it implicitly trusts absolutely everything that walks through the front door. So how do we secure those borders? That takes us to section 2, securing your API borders. We are going to look at the specific layers that validate, protect, and observe the traffic trying to come into your application. Understanding the exact order of the request lifecycle here is absolutely crucial. Before a request ever actually hits your controller, it has to survive what is essentially a gauntlet. Step 1 is middleware. This is your airport body scanner. It checks raw, express-level security headers or rate limits just to ensure nothing obviously dangerous enters the building. Step 2 is the guard. Think of the guard as a nightclub bouncer. Before you even get near the dance floor, the bouncer checks your ID for authentication and VIP access. It's a simple yes or no. Step 3 is the interceptor. Imagine this as a sandwich wrapping your handler. The top piece of bread runs before the request, maybe starting a performance timer, and the bottom piece of bread runs after, maybe stopping that timer or completely transforming the output data. Finally, step 4 is the pipe. This is your water purification system. Raw water flows in, impurities like invalid fields or bad data types get filtered out, and only clean, perfectly formatted data actually reaches your handler. Let's actually zoom in on how that pipe purifies data using a DTO, or data transfer object. Think of the DTO as a strict customs declaration form at an international border. Before anything is allowed to enter your application, it must declare its exact contents on this specific form. Combined with a global validation pipe, which acts as your highly suspicious customs officer, the system automatically enforces this contract. Any undeclared items, they are stripped out and confiscated. If the form itself is malformed or missing required info, you are rejected right at the border with a 400 bad request before you ever even see the service layer. Now listen closely, because this next rule is absolutely non-negotiable. Never, ever accept ID, tenant ID, or user ID as client-provided DTO fields. Think about it. These are server-assigned values. If you accept them from a client's request body, you are opening up a massive, catastrophic security vulnerability. A malicious client could just pass in someone else's ID, claim to be any user, operate within an entirely different organization's tenant, or overwrite any record they want. You have to keep these fields off your customs forms entirely. No exceptions. All right, moving on to section 3, the engine room. Now we're going to dive deep into the internal wiring logic that makes this whole system incredibly testable. We mentioned that power grid analogy earlier, but let's look at how dependency injection really functions day to day. Think of it as a professional, high-end staffing agency. Instead of a head chef having to go out onto the street and personally hire their own staff, the chef just declares to the agency, hey, I need a sous chef and I need a pastry specialist. On opening day, the agency automatically sends the exact right people. So why does this actually matter? One word, testability. In your test kitchen, the agency can just send in stand-in actors, or mocks, without you ever having to change a single line of your actual production code. The chef cooks exactly the same way, totally unaware of the swap. It's brilliant. Now, how those provided instances are actually managed over time, that is determined by scope. Think of scope as how the office coffee gets made. The default scope, which is a singleton, is like the communal coffee maker. One single pot is brewed in the morning and everyone shares it for the entire lifetime of the application. The request scope, on the other hand, is like brewing a brand new, fresh cup of coffee for every single visitor the moment they arrive. And transient? That's like a new cup magically materializing every single time a class even asks for one. You need to be really, really careful here. If you make a provider request scoped, every single class that depends on it becomes request scoped too. It cascades all the way up the tree. And instantiating hundreds of brand new classes for every single HTTP request carries a very real, very heavy performance cost. Use it sparingly. Next up in our engine room is the database layer, specifically type ORM migrations. See, your entities in your code are just like blank government form templates. They define the exact rules of the data. But when you need to change those rules over time, you use migrations. Think of migrations as Git commits, but for your database schema. They are carefully versioned, they run in a specific order, and they are fully reversible. You never alter a past migration. If you make a mistake, you write a new migration to undo the problem, exactly like your Git history. And here is a rule that will literally save your career. Never, ever use synchronize equals true in your production environment. It will blindly alter your live database on startup, potentially dropping entire columns silently. You will lose data. Always, always use migrations. All right, so we have a secure, incredibly well-wired application. But what happens when your project actually gets popular? How do we scale this architecture for teams of 10 or more developers and massive enterprise-level data loads? Let's open the doors to the penthouse suite of NestJS. Section 4, Enterprise Scale. These are the advanced patterns you need to prevent catastrophic production failures. The absolute first pattern you need to know is CQRS, Command Query Responsibility Segregation. Look, at scale, mixing your reads and your writes in one giant service file creates this monstrous God class that is practically impossible to test or maintain. CQRS solves this by splitting them up into two completely separate kitchens in a restaurant. Your commands are your hot orders kitchen. They change the state of the menu, they cook the food, and they mutate data. Your queries are your cold reading kitchen. They only describe what is already available, serving up pre-plated dishes without ever even turning on an oven. There is zero confusion between the two. The golden rule here: the handlers for these commands and queries must be incredibly thin. They literally just route the specific message to the specific service, and that's it. Now let's talk authentication scaling. A lot of folks completely gloss over cryptography when dealing with JWTs and microservices. With HS256, you basically have one shared secret. It's a master key. Anyone who has it can lock and unlock the doors. The problem: if even one downstream service is compromised, the attacker now has that master key and can forge completely valid tokens for literally anyone. RS256, however, is totally different. It's a royal wax seal. It uses an asymmetric key pair. Only your dedicated auth service holds the private key, the actual royal signet ring, to sign new tokens. All your other microservices just hold the public key, which only lets them verify that the seal is genuine. A compromised downstream service can't forge anything because it never had the ring in the first place. For any real enterprise app, RS256 is the only correct choice. Moving over to data fetching performance, especially if you're using GraphQL, you are inevitably going to hit the dreaded N+1 problem. Imagine querying a list of 100 posts, and for every single post, your server does a separate lookup for the author. That is 101 separate database queries just for one page load. It is a silent, absolute performance killer. Data Loader solves this by acting like a really smart barista. Imagine 100 customers walk into a cafe, and for every single cup, the barista literally runs down the street to the warehouse for beans. That's insane, right? Data Loader is the barista who waits, writes down all 100 orders, makes one single trip to the warehouse with a complete list, and fills all the cups at once. It intelligently batches 100 individual lookups into one single database query. It's a lifesaver. Finally, let's look at multi-tenancy. This is when your application serves multiple different client organizations from one single database, kind of like a vast cloud storage facility. A data breach here isn't just bad, it's business ending. For B2B apps, you typically use shared tables with a tenant ID column on every single row. Crucially, as we mentioned earlier, this ID must come only from a securely verified JWT token, and it should be placed in a request-scoped context. For maximum safety, you want to build an add-authorized decorator that acts as an unbribable turnstile right in your database corridor. Every single query has to pass through it, ensuring absolute data isolation between your clients. As we wrap up our skyscraper blueprint today, I want you to remember this quote: NestJS doesn't feel weird because it's complicated, it feels weird because it's explicit. Decisions simply aren't made in the shadows here. The framework actively forces you to make every decision, but the beauty is it places those decisions where they are highly visible and completely testable. Modules stop spaghetti code before it starts, guards prevent unauthorized access at the door, CQRS prevents messy God classes, and tenant turnstiles prevent catastrophic data breaches. Once you truly embrace this vocabulary, what felt so intimidating on day one transforms into a highly reliable, perfectly repeatable architecture. So the final thought I'll leave you with today is this: are you ready to trade the hidden magic that breaks at scale for true explicit architecture that you fully control? Thank you so much for joining me for this explainer. Keep learning, keep building, and I'll see you next time.